Hello everyone, welcome to Dakshana A classroom program. So I hope everyone has done their best in the exam, that it's DT03 for NEET. And today I am going to discuss the solution of the questions. So I hope if you are having still problem in any question, you should be understanding after going through this video. In exam, our main objective is for the practice exam is not to score the best. Beside that, our objective is also to learn new things. कुछ ऐसे questions which you are not knowing earlier, after the exam at least you should be knowing those things, those questions, so that in the final exam if similar questions or same questions is asked in that exam you should be able to answer it. So our target is actually the final exam, but we are practicing actually and improving ourselves. So no need to worry, even if you are not able to solve some of the questions in the exam, at least learn some of them, or learn those questions now after going through this solution. So first you read the problem carefully and let me start with question number 1. So यहाँ पे दे रखा है the figure below shows current in the part of the electric circuit, the current I is. तो यहाँ पे आपको एक सर्किट इस तरह का दे रखा है. This is question number 1 and like this it's given this. Simple application, it's application of Kirchhoff's law or Kirchhoff's current law. Here current is going this way and this way, and this current is asked to find. यहाँ पे ये दे रखा है आपको 2 ampere and this is 1 ampere and this is 1.3 ampere. तो जो Kirchhoff's law है वो क्या कहता है, at any junction the net current should be 0, or you can write net incoming current should be equal to net outgoing current. तो यहाँ पे देख सकते हैं कि 2 ampere coming, so means here the current will be like 4 ampere. So at this junction if we apply KCL, Kirchhoff's current law. Similarly if we apply at this, so now current coming here is 4 ampere, going is 1 ampere, so here current should be 3 ampere. Clear? Simple thing. Now if I apply same KCL at this junction, then 1.3 ampere current is going, 3 ampere current is coming, so here how much? So current 3 should be equal to 1.3 plus, let me write this current I, and that comes out to be I is equal to simply it's 1.7 ampere. So your answer from the question is A for question number 1. Question number 2. A radio capacitor of variable capacitance is made of n parallel plate, each of area A and separated from each other by a distance d. The alternate plates are connected together. The capacitance of the combination is. ठीक है, तो यहाँ पे देखो मैं क्या करता हूँ, अभी हम 3 प्लेट ले लेते हैं और let's take 4 plates. तो alternate plates are connected like this and like this. ठीक है ना, 1 2 3 4. तो अल्टरनेट प्लेट्स को कनेक्ट कर दिया गया. अब ये देखो कि अब C इक्विवेलेंट कितना हो जाएगा. तो इस तरह की प्लेट्स को इस सिस्टम के लिए हम क्या कर सकते हैं, यहाँ पे हमारे पास कितनी है, 4 प्लेट्स हैं. और देखो 1 and 2 मिलके these 2 plates will form 1 कैपेसिटर. तो मैं इसको अगर लेट्स से इसका पोटेंशियल A ले लेता हूँ, इसका पोटेंशियल B ले लेता हूँ. इस तरह की प्रॉब्लम को सॉल्व करने का तरीका ये है कि आप दोनों पॉइंट्स को मार्क कर लो यहाँ पे. ठीक है, दिस इज A, दिस इज B. अब देखो A और B के बीच में ये प्लेट A है और ये प्लेट B है, तो इनके बीच में एक कैपेसिटर है, कनेक्ट कर दो. ये प्लेट B हो गई और ये प्लेट A, तो इनके बीच में एक और कैपेसिटर है, वो भी कनेक्ट कर दो दोनों के बीच में. तो ये कैपेसिटर हो गया, ये हो गया, और यहाँ पे देखो ये B और ये, तो इनके बीच में एक और कैपेसिटर है, तो वो भी कनेक्ट कर दिया. और ये सभी क्या है, तीनों पैरेलल में. तो जब 4 प्लेट अपन ने ली हैं, देन हाउ मेनी कैपेसिटर्स वी आर गेटिंग, 3 कैपेसिटर एंड दैट टू इन पैरेलल. तो C इक्विवेलेंट यहाँ पे कितना हो जाएगा, बेसिकली राइट 3C एंड C इज इक्वल टू A एप्सिलॉन नॉट बाय D, राइट. इन सिंपल जनरलाइज फॉर्म अगर यहाँ पे n प्लेट्स ऐसे ही होंगी तो कैपेसिटेंस कितना हो जाएगा, नंबर ऑफ कैपेसिटर विल बी n-1. तो आपका C इक्विवेलेंट फॉर दिस क्वेश्चन नंबर 2 विल बी here, it will be answer is B, and that is equal to C equivalent is equal to n-1, because 4 plates we are getting 3, then n plates, then it will be n-1 and A epsilon naught by D, and this is your answer, right? So that is question number 2. And question number 3. The ratio of resultant capacities when three capacitors are connected first in series and then in parallel. तो यहाँ पे अपने पास हैं तीन capacitors like this and this. तीन कैपेसिटर को पहले सीरीज में 2 माइक्रोफैरड, 4 माइक्रोफैरड and this is 6 माइक्रोफैरड. ठीक है, तो अभी इनको सीरीज में कनेक्ट किया गया है, तो यहाँ पे सीरीज पे इक्विवेलेंट निकाल लेते हैं अपन. तो इन दोनों का कितना आ जाएगा देखो, लाइक अदरवाइज 1 by you can write 1 by C equivalent is equal to what, 1 by 2 plus 1 by 4 plus 1 by 6, and LCM 1 by C equivalent you can write, this is LCM is equal to how much, it will be like 12, and if we add it, so this is 6 plus 3 plus 2, and that comes out to be, this implies C equivalent in series it comes out to be how much, 12 by 11 microfarad. I hope you are understanding. Simple thing in series connection. Second case में कि इन तीनों कैपेसिटर को ही पैरेलल में कनेक्ट कर दिया गया है like this, 2 4 6. तो C equivalent in parallel कितना हो जाएगा, simple addition, that is coming out to be 12 microfarad. Now what is asked in the question, it's asking okay, are connected in series and then in parallel, and then you are asked to ratio of resultant. So basically यहाँ पे आपको पूछा गया है C equivalent in series divided by C equivalent in parallel. So this divided by this, so that comes out to be 12 divided by 11 divided by 12, and this comes out to be 1 by 11, that is 1:11 is your answer, and which is matching with the option A. So this is your problem number 3. I hope you are getting it. Okay, so next is problem number 4. So here it's given it condenser A of capacity. So here we have condenser A, capacity is 4 microfarad, and it's charged up to 20 microcoulomb. This is, and another condenser B, this is B, and its capacity is 10 microfarad and is charged up to 40 microcoulomb, and these two are connected in parallel like this. Okay, so first let me write, this is VA and this is VB. So before connection is made, let me check the potential. So we know actually Q is equal to CV, so you can write actually V is equal to Q by C, simple, directly you can write. So let me check VA, how much, this is Q, this is like 20 divided by 4, that is 5 volt, and VB is equal to how much, this is 40 divided by 10, that is equal to 4 volt. So means which capacitor is at higher potential, and you can see here this implies VA is greater than VB. So means charge here flow from high potential to low potential, right? So that's why we can check now option, the charge flow from B to A, no, it will be from A is at higher potential, so charge will flow from A to B, and you can till what, till the potential is becoming equal, right? In such cases, like it's not the charge must become equal, it should be the potential must become equal, right? So here the charge flow from A to B till common potential is reached, and your option C is correct here. So question number next 5, equivalent capacitance between A and B in the adjoining figure. Okay, तो यहाँ पे आपको प्रॉब्लम दे रखा है, this is the diagram given, and capacitors connected this way, this and this, ठीक है, and this is 9 microfarad, 9 microfarad, 9 microfarad, and this is 3 microfarad, and these are points A and B. So आप इसको ऐसे समझ सकते हैं, actually this system is equivalent to, like you can treat it A, मैं इसको A कर देता हूँ, and this is my B, and these three 9 9 9 9 9 9 and this is 3 all in microfarad. तो इस तरह से कनेक्टेड हैं, दिस सिस्टम इज इक्वल टू दिस. अब आप देखो इसका बहुत आसानी से निकाल सकते हैं. सो दिस इज 3 in parallel with 9, so here 9 microfarad capacitors in series. So what will be the C equivalent for this part? This will be like, you can write directly, I can write it will be 3, and in parallel with 3, so C equivalent you can write it's simply equal to 6 microfarad, and your option matches here with B. This is answer. I am not going much detail because these things are, I think, straightforward series parallel combination, so you should be able to understand them straightforward, right? Okay, let me see next question number 6. So a capacitor of capacitance C has charge Q and energy stored is W. If the charge is increased to Q, the energy stored. Okay, so next question number 6. तो यहाँ पे Q, C and energy is W, and we know actually W is equal to half like Q square by 2C. Q square by 2C is the energy stored in the capacitor. So this is given as W. Now if Q prime is made 2Q, means charge is double, then W prime will be what? This you can write 2Q whole square divided by 2C, means Q square divided by 2C, and this comes out to be, you can say, 4Q square by 2C, and this is what? W. So W prime is equal to what? 4 times of W. So your energy will become 4 times, and your answer matches with D. D option is the correct answer. Next question number 7. Alright, so in the circuit diagram given below, the value of the potential difference across the plates of the capacitor are. Alright, so देखो इसके लिए यहाँ पे आपको प्रॉब्लम दे रखा है. This is a battery like this, and capacitor, another, here another battery and another capacitor, right? And this is 13 kilovolt, it's 12 kilovolt, and this is 7 microfarad, and this is 3 microfarad. Now you are asked to find the potential, okay, in the circuit diagram, find the value of the potential difference across the plates of the capacitor. So is like across this capacitor, you are asked to find the potential difference. First thing is, if I am going in this circuit, this means like this complete is a, like you can say a series. Both these capacitors are actually in series. So in this situation, the charge on both the capacitors should be same, or in other word you can understand it actually like this is your isolated system, right? So like if on this plate, if it is like negative charge is appearing, then here positive charge will be appearing, and charge here must be equal, because there is no battery can't like generate some charge. It's like it will be like just supplying charge from one side to another. It's not generating, understanding, remember that. So here in this it will be like battery will pull the positive charge from here and supply it there. So that's why I can say the charge on here, it's let's say Q, then charge here also it will be Q. Now I can go with the KVL. So if I start from here, then KVL, so this implies plus 13. I am taking everything in kilovolt, and let's say kilo, and if I am going here, then it will be minus V is equal to Q by C, you know it actually. So let's say Q divided by C, it's 7, and here automatically I will take care of the things for magnitude, and next is plus 12, and then here it will be like, if I'm going from this is positive, it will be minus Q by 3 equal to 0, right? And let me simplify it. So this comes out to be here from this positive, negative, minus Q by 7, plus and minus. So this is, so after solving it, we are getting how much, like it will be 25 kilo, and here LCM, if we are taking, it's 21 and it will be 10. So 10 Q by 21 is equal to 25 kilovolt, right? And solving, we are getting this implies, okay, I'm having a little bit less space. So we got simply from here Q is equal to 25 into 21 divided by 10, right? And now Q I need actually potential across 3. So potential will be Q by 7. So V, let me write it here, V across 3 microfarad will be this whole divided by 7. So then you can see it will be like 25 multiplied by 3 divided by 10. So that will be like 25 multiplied by 3 divided by 10, that is equal to 7.5 kilovolt. And similarly, if I next is here 7 microfarad, just wait, This I calculated actually across. Wait, let me just do the calculation properly. Okay, see, so I hope you are clear with this. Here we applied KVL in this loop and we started from here. So plus 13 minus q by 7 plus 12 minus q by 3. And solving this, we are getting q is equal to 25 multiplied by 21 divided by 10. Okay, so I need actually voltage. I'm just say like doing normal calculation. My voltage will be final also in terms of kilovolt. Right, so this is Q I got and charge on both the capacitors. Now potential difference across 3 microfarad, you can write Q divided by its C, and that comes out to be 25 multiplied by 21 divided by 10 multiplied by 3, and this comes out to be basically 25 multiplied by how much, 7 divided by 3, and 3 cancel, so it's 10, and that comes out to be 17.5 kilovolt. Similarly, V, potential difference across 7 microfarad will be, you can write Q across 7 divided by C, and this comes out to be 25 multiplied by 21 divided by 10 multiplied by 7, and this comes out to be 25 times 3 divided by 10, and that is 7.5 kilovolt. So the answer is potential difference across 3 17.5 and across 7 it's 7.5, so your A option matches here perfectly. That is question number 7. Next is 8. The current through a wire connected to a condenser varies with the time. According to this, the charge transport to the condenser from t is equal to 0 to t is equal to, so here you are given with I, and I is a function of time, 2t plus 1 ampere. And we know I is equal to what? dq by dt. So we can simply integrate it, and you are asked to find q for t is equal to 0 to t is equal to 5 seconds. Q you are asked to find. Clear? This implies, so dq is equal to 2t plus 1 into dt, integration how much, 0 to like this is q, and 0 to 5 seconds. Integrating it, q we are getting, this is integration t square plus t, and substituting the values 0 to 5. If I substitute the 0, everything will be 0, and substituting 5, it's 25 plus 5, and that comes out to be how much, 30 coulomb. So the answer is here 30 coulomb, that is matching with option C. So this is problem number 8. Okay, so next question number 9. Here it's saying current flow in a wire of circular cross section. So this is a wire of circular cross section, and with a free electron traveling with the drift speed v, if an equal current, so here we know I is equal to NEA drift, right? And here it's talking about two cases when like radius is r, in another case r is equal to 2r. R prime means radius is becoming double, so you can write area A initially. For this case it's A, and this case A prime will be what, how much, it's 4A. And it's saying in both the cases the current is remaining same. So I, if I write this, and N is the basically actually depends on the material, so material we are keeping constant. That means N will be, and E is the charge of electron, so I can write I is equal to NEAVD, initially it's V, and here I will write, for this case it will be NEA prime into VD, or you can write V prime, and these two I's are equal, and it's NEA is how much, 4A into V prime. So just solving it, we are getting V prime is equal to what, V by 4. So your drift velocity will be 1 by 4th or V by 4. Answer here, answer matches with like C option. Next question number 10. The current I coming from the battery and the ammeter readings are. So here the problem given, you are given with this system, battery, and this. Okay, so here its battery is 2 volt and it's 4 ohm, 4 ohm, 4 ohm, 4 ohm. See, listen it. So if I take just these 2 points, actually if I'm taking this circuit, then this all are simple like resistors, and I can say these all 3 are in what? In parallel combination, right? So this system can be equivalently written as this is, and here what is it is asking? It's asking something actually, just let me say. It's current I coming from the battery and the ammeter reading. All right, so ammeter reading means I need current in this circuit actually, and current through the battery. All right, so this is 4 and this is your battery, and now see all these 3 if I combine, then it will be like this circuit, and it's 4 by 3 and it's 4 and it's 2 volt. I hope you are understanding this, because I am like sort of like taking it outside, and these 3 like resistors are in parallel, then C equivalent R equivalent will be 4 by 3 ohm, and this as this side is simply here actually. So now this is the simple current flowing like this way. So now I can write the current through the battery, it will be equal to what? I can write R equivalent is equal to how much? 4 plus 4 by 3, and that is equal to 12, 16 by 3, right? R equivalent ohm. So I through the battery will be V by R, and that comes out to be 2 divided by 16 multiplied by 3, and this is coming out to be 3 by 8 ampere. I hope it's clear. And now see, from the battery current is coming is 3 by 8 ampere. Now you can see this it's coming from the battery, and it will be divided in this resistor, this, and all 3 are equal. So I can say definitely 1 by 3, 1 by third, 1 by third current will be divided in each. So the ammeter reading will be 1 by third of this. So ammeter reading I can write it's 1 by 8, because 1 by third means 1 by 8 ampere. So the answer here readings are actually it's 3 by 8 for battery, and ammeter reading it's 1 by 8, and that option matches with the answer A. Okay, so next question number 11. Which arrangement of 4 identical resistance should be used to draw maximum energy from a cell of voltage V? Okay, so here we have cell of voltage V, and we want maximum power, right? And that should be equal to V square by R. So what it implies, V is constant because cell is constant, so we need a combination where R should be least, right? And if we are having n number of resistance, in which way we should connect the resistances so that we are having least resistance? That is when they are all connected in parallel, is it? So that means simply resistance should be connected in parallel. Now here we have few options, few combinations. So first, parallel and series, definitely not. Second, all parallel. Third, series parallels, and fourth also. So definitely you can write answer, your B will be the right option, where all resistances are connected in parallel. How many resistances here? Yes, so when all these are connected in parallel, then R. So R equivalent will be here R by 4. You can check actually in other cases it will be like even more than this. So when R is greater than this, then definitely power will be less than this maximum value. So our right option here for question number 11 it's B, right? And next question number 12. Let me just erase it first. Okay, next question number 12. So here 4 resistances are connected as shown in the figure, and you are asked to find the effective resistance. This given problem is like this. Its point mentioned as A, and this is B, and here you have resistances like this. It's 4 ohm and like this. So it's 1.6 ohm. This is 4 ohm and this is 6 ohm. It's a little bit different problem. The point is here there is one proper method to solve this type of problem when straightforward like simple series parallel combinations are not appearing somewhere, or even maybe the arrangement is not straightforward where we can simply see it's like series parallel combination. In such cases, first you need to simplify it to simple diagram and then it will be straightforward answer. Okay, so let me just tell you the approach. So what we do here, actually let's say it's point A and it's point B, and here like you can see this point complete is A and this is B, this is B, but here this point is having different potential. Let me write it C. So now what we do here, actually we mark all these points A, B, and let me mark point C. So we will try to convert this diagram to simple diagram. So now between A and B, is there any resistance? So see, A potential, this is up to A and this is B. So between A and B there is one resistor, that is 4 ohm, right? I hope you are getting it. We trying to simplify this diagram to simple form where we can see it's simple series parallel combination. It's visible because from here it's not clearly visible. So what I did, simply like all the points which are having different potentials, you mark all those points and then check between 2 points, any 2 points A and B, is there any resistor? So A, this is B point and A point, actually it's here but it's connected with the wire, so means this is complete A potential, so means this point is also A, right? So it's A and B, and we can see 4 ohm is the resistor connected between point A and B. Now C, so is there any resistance between C and B? So this is B and this is C, so you can see it's like this is your resistor, that is 1.6 ohm between C and B. Is there any other resistor between C and B? So this is a C and B, only 2 connections and there is no another, right? And now between C and A, so C and A, this is 4, C and A, this is 4 ohm, and C, like this is C and this is A, 6 ohm. So we have 6 and 4, and this is your circuit. Now you can see this is still appearing much easier. So now what is that? These two are in parallel, this with this series and complete parallel. So now I can write it here actually. So we can now simplify it. All right. So see, these two in parallel, then it will be, the circuit will be what? 4 and 6 in parallel, it will be like 2.4. So it will be like this is C, this is A, this is B, so this is 2.4, this is 1.6, and these two will be 4 and this is 4, so 4 and 4 in parallel, so it will be like R equivalent will be between AB, it will be 2 ohm. I hope you can simplify it, check it. That is question number 12, and your option matches with the answer D, like answer matches with option D. Next question number 13. N conducting wire of same dimensions but having resistivities 1, 2, 3 and so are connected in the series, the equivalent resistivity of the combination. Okay, so we have an identical wire. Identical wire means like dimensions are identical, it's mentioned, and conducting wire of same dimension. Basically I should not write identical, and wire of same dimension. So same dimensions mean R, we know rho L by A. So here L and A are same actually, and their resistivity rho 1 is 1, 2 and so on. It's like that. The equal all are connected in series. So here you can write this and so on. N 1, 2, 3, 4 and up to N. So here what I can write, R equivalent is equal to what? Rho 1 is what? 1. So I can write it's L by A. Next it's 2L by A, 3L by A and so on, NL by A. This should be your R equivalent because resistance this and all are connected in series. So simple series combination means simple addition, algebraic addition of all the resistances, and this implies R equivalent is equal to L by A. I can take it out, it's 1 plus 2 plus 3 plus so on up to N, and addition of this is L divided by A. This is equal to how much? N into N plus 1 divided by 2. So this is your R equivalent. Now see, it's talking about the equivalent resistivity. So resistivity means if I am connecting all the wire, is it means like basically next I am having a complete wire. So then its length should be what? NL. Its area of cross section should be A, and resistivity should be rho equivalent. So R equivalent here will be like what? Rho equivalent into L, that is NL divided by A. Now these two should be equal. So if I just compare L, this all gets cancelled, one N gets cancelled, and this implies here we are getting rho equivalent is equal to N plus 1 by 2, and this is your answer. So which is option like matching, that is with the option B. So this is question number 13. Next, question number 14. Here it's given the resistance of the bulb filament is 100 ohm at like 100 degrees Celsius if the temperature, so on. Like, so here alpha is given as 0.005 and per degree Celsius. This is alpha, and here R, we know it's R0 1 plus alpha delta T. Remember that here this R0 is actually 0 degrees Celsius. The resistance should be at 0 degrees Celsius, not at 100 degrees Celsius. So I can write first condition, I can write it's 100 is equal to R0 1 plus alpha into delta T is how much? 100 for 100 degrees Celsius. In second case, it's asking like its resistance will become 200, temperature I need to find. So this you can write actually 100 minus 0 because R0 is at 0. Next I can write it's 200 is equal to R0 will remain still same, alpha into delta T is T minus 0. So this will be your, next we can simplify it. So if I just simply divide it, then this is cancelling out, it's 1 by 2 equal to it's like 100 1 plus 100 alpha divided by 1 plus alpha T. Multiplying it, so we are getting 1 plus alpha T is equal to 2 plus 200 alpha. Is it? 1 simply like it's alpha into, so alpha 0.005 into T, and this is coming out to be 1 plus how much? It's like 200 multiplied by 0.005, so 20 gone, and it will be like 1, it comes out coming out to be 2, and this divided by, so T is equal to 2 divided by 0.005, that means 30, and this comes out to be how much? 400 degrees Celsius. So the answer is 400 degrees Celsius, that matches with the option B. Next, question number 15. 4 conductor of same resistance connected to form a square. Okay, so 4 conductor of same resistor connected to form a square like this, this, this. So it's R, 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 R. Tick. If the resistance between the diagonally opposite corner is 8 ohm, so means this diagonally opposite corner, so R equivalent, let's say A, B, C, D, so R equivalent AC is given as 8 ohm, or in terms of R, what it will be like? This will be like 2R, this will be 2R, and 2R in parallel, so means R equivalent will be equal to your R, and that means it's 8 ohm, right? And next thing is the resistance between two adjacent corners, that means like R equivalent between AB it's asking. So that will be like equal to what? AB means you can write this system, this. It's A and it's B. So it's R, R, R. So these three are in series and this R is in parallel. So then your R equivalent will be what? 3R into R divided by 4R, and that comes out to be 3R divided by 4. R value I can substitute here, that is 8 ohm. So then after solving we are getting this is 3 into 8 divided by 4, and that is coming out to 6 ohm. So this is your answer, and that option matches with the D. Answer matches with the D option. Next question is 16 number. Okay, 4 wire made of same material. Same material means it's talking about rho is equal to same, constant or same I can say. Now it's same material have different length and radii, the wire having resistance in the following, okay, more resistance. So R is equal to rho L by A. So means if we want more resistance, then L should be higher and area should be least. And then you can, because rho is same for all because material is constant. So you can say L like maximum here, it's like either option A or C. And then we need to check actually for area, means radius should be least, and which is least in case of C. So overall your C will be the correct option. Otherwise you can just check the value of L by A for each case, which is having like the maximum value will be the maximum resistance. So that option matches with the C, or answer matches with option C. Sorry for that. And next question number 17. Okay, so it's saying two metal plates are separated by distance d, and so here initially we have like two metal plates separated by distance d, area A, and so on. So C here is equal to what? A epsilon naught divided by d. Clear? Alright, next it's saying metal plate of thickness t and same area is inserted between the condenser plates. So now what is happening? Next case, this, but now a metal plate, t thickness metal plate is inserted between the, so now here C prime is equal to A epsilon naught divided by D minus T plus T by K, and K metal is infinity, so this means this will be term will be simply 0. So your C prime is equal to what? A epsilon naught divided by D minus T, right? And now I can rearrange it, so I can take it simply A epsilon naught divided by D, and this is 1 minus T by D, and this is equal to what? D. So C prime is equal to 1 by 1 minus T by D times C. So you can see it's asking like the value of the capacitance increases by this much time, so 1 by 1 minus T by D times, and that option answer matches with the option D. So this is up to problem number 17. Okay, so next question number 18, and it's asking the potential difference between point A and B, and this is the system given to you. This battery, and like this, and this is point B, and this is A, and current here flowing 2 ampere. Resistance is mentioned 1 ohm. This battery 9 volt, this is 2 ohm, this is 3 volt, and this is 3 ohm. So this type of problem, there is proper straightforward, like there is one method. So first thing is here current is flowing from A to B, means A should be at higher potential. Then we will, let's say the potential of point is A. Okay, then now we are going in this way. So when we are going in the direction of current, across the resistance potential decreases. That's why like this minus this, and it will be minus IR. V is equal to IR, so it's 2. Now it's going from here to there, then it's plus 9. Again current, so it's minus 4. 2 into V is equal to IR. Then going, then it's minus 3. Across this, it's like 3 into 2, and that should be equal to VB. Right, so we can write here actually now. So this VA, it's minus 2, and okay, minus 2, this minus 6. Listen, minus 2, and this is minus simple calculation. It's plus 9, and it's 2, 6, 9, and 12. So it's coming out to be 9, 12, 15 equal to VB, and this implies VA minus VB is equal to how much? It's right, 6 volt. So your options matches with the answer matches with option A. Next question number 19. Method is this, you should be clear with that. The resistance between A and B, so here also it's straightforward things actually. So just once again, it's not clearly visible. Resistance between, alright, let me first draw the diagram. This is point A, and it's point B, and here resistance, here it's 4 ohm, this is 2 ohm, and this is 2 ohm, this is 4 ohm, 8 ohm, 2 ohm, and it's 2 ohm. So now listen it, 4 ohm, 2 and 2, this is in series, also 4, 2 and 2, 4, and this is also 4. Now you can see actually it's 4 divided by 4 and 4 divided by 4, so it's basically a balanced Wheatstone bridge. In that situation, this simply get removed in case of balanced Wheatstone bridge. So now we are left with 4 and 4, it's 8, and 4 and 4, it's 8, and 8 and 8 in parallel, so that means our equivalent is coming out to be 4 ohm. That should be your answer, which is actually B. Next question number 20. Cell of EMF 6 volt is being charged by a 2 ampere current. If the internal resistance of the cell is 2 ohm, the potential difference across the terminal of the cell. That's good question actually. So here we have like cell. So cell has internal resistance and this complete make a cell. Being charged, that means actually the current is entering to the positive terminal of the cell, then it is termed as charging a battery. If current is withdrawn from the positive terminal of the battery, that in that situation your battery is doing work or battery is supplying the power. Here battery is absorbing the power actually, right? So here 2 ampere current is entering here, like 2 ampere current. This, let me write, this is point A and this is B. Okay, the potential difference across the terminal of the cell. So definitely B will be at higher potential. We can go from either way. Alright, so let's say it's now it's asking about EMF is 6 volt, it's given, and internal resistance is also given or not. Yes, internal resistance is also 2 ohm. So now we need to find VB minus VA. So we can start from here again, exactly this way. What is VB? Now if we are going, then it's minus 6, and going in the direction of current, so it's minus 2 into 2 equal to VA, and this implies VB minus VA is equal to 10 volt. This is your answer, and which matches with the option B. Next question number 21. 10 meter long wire of resistance 15 ohm is connected in series with a battery. So we have like battery, and this is a wire, basically 10 meter long and 50 ohm resistance wire connected with the battery. All right, okay, connected with the battery in series with all right, 2 volt, no internal resistance, and resistance 5 ohm. Okay, so with internal resistance is 0, but here we have 5 ohm resistance. This is the system given. Now your potential gradient across the wire. Potential gradient का मतलब होता है, the meaning of potential gradient means potential difference per unit length across this wire. So first let me like just get the like total R will be like 20. So I is how much? 2 divided by 20, that comes out to be 1 by 10 ampere. This is the current. Then potential difference across wire will be V is equal to IR. So this is 1 by 10 multiplied by, it's like 15, that is 1.5 volt. This is the potential difference. Now potential length of the wire is 10 meters. So potential difference per unit length. Potential gradient. Potential gradient means potential difference per unit length. So that comes out with this divided by 10 meter, and this comes out 0.15 volts per meter, and this is your answer for potential gradient. Next question number 22. Okay, if the external resistance is equal to internal resistance of the cell of EMF A, the potential difference across its terminal. So here we have like this is a cell, this is external resistance and this is internal resistance, its EMF is E, and it's given both are equal. So in that situation I is equal to what? And here this I can write I is equal to E divided by 2R. And then potential difference across this, let's say A and B. So V, I can write VA minus I. I'm going in the direction of current, so it's I is equal to E divided by 2R multiplied by R, and then plus E equal to B, right, across this battery. And this coming out to be VB, because definitely B will be at higher potential, minus VA is equal to E by 2, and this is an answer which is matching with the option like A. 22, it's A option correct. Okay, next question number actually 23. If identical cells each having 20 volt are connected in parallel, then the EMF. So 23, it's straightforward answer. Actually, when we are connecting n cells in parallel, then EMF equivalent is still remain EMF of one cell. That means it's 20 volt answer, and that is actually your C option. Question number 24. 25 watt and 220 voltage bulb, 100 watt and 220 voltage bulb are connected in series across 440 watt. All right, so here this implies P is equal to V square by R. This implies R is equal to V square by P. Clear? So for this I can write R1 is equal to V square 220 whole square divided by 25, and R2 for this it's 220 whole square divided by 100. R1 R2 we got, and here from here we can see actually this implies R1 is greater than R2. Right now it's saying connected in series across, so this is R1 R2, this is connected across 440 voltage. Remember this, if R1 R2 are equal, then in series the potential difference is actually equally divided, but here potential difference is this and R1 R2 are not equal. So here you can see the current will be same in both the like resistors, so V will be directly proportional to I into R. So means you can write potential difference is directly proportional to resistance, means higher is the resistance, higher is the potential difference. 25 watt 220 voltage like rated voltage, this means when this bulb is operated at this voltage it will consume this much power. Another point here is that this bulb can work at potential less than its rated volt like at potential difference less than its rated voltage, but it will fuse if the potential difference across the bulb increases or goes beyond the rated voltage. Point is here we have 440, so if R1 R2 were equal, then it will be equally divided 220 and both bulb will be working fine. But here current is same, so I can say the potential difference now across the resistor which is having high resistance will be higher because V is directly proportional to R. So you can see here R1 is higher, so potential difference across this will be greater than 220 because more than half of this. So this bulb will fuse and this will work properly. There will not be any problem in this bulb. So answer like only 25 watt bulb will fuse. So your B option is correct here. 24 problem number. Next is 25. There are 5 tube light each of, okay, so like we have 5 tube light and it's like 40 watt. All right, these are used on an average 5 hours per day. In addition, there is immersion rod of 1500 watt and used for 1 hour per day. The number of units of electricity consumed. So let me just first calculate how much electricity is consumed in one day. Power or like electricity consumed in one day. This will be equal to, because per day it's like so watt multiplied by time, like watt hour I'm calculating, it's basically, so this is 40 multiplied by 5 tube lights, 5 multiplied by 5 hours per day, so this is coming out to be 25 and into 4 it's 1000 watt hour plus this, so it's 1500 watt multiplied by hour, that is 1, and it's coming out 2.5 like 2500 watt hour, right, per day. Now it's saying number of units of electricity consumed in 1 month. In 1 month, then it will be like 2500 multiplied by 30, and that comes out to be 75 1000 watt hour, right? This much power or electricity is consumed. It's saying like unit, so 1 unit of electricity means 1000 watt hour. This is called 1 unit, so means how much unit is consumed, so that means 75 units of electricity is consumed. Your answer matches with the option C. Next question number 26. Let me erase it now. Electric bulb 220 voltage and 100 watt, power consumed by it when operated at, right, so here bulb is 220 volt and 100 watt. Resistance is equal to what? 220 square divided by 100. This is resistance. When it is connected to 110 voltage, then power is equal to what? V square by R, and power is equal to V square is this 110 whole square divided by R, that is 220 whole square multiplied by 100. This coming out to be 100 divided by 4, that is equal to 25 watt. So the answer here is D, that is 25 watt for question number 26. Okay, let me. Okay, next question number 27. It's saying 5-degree rise in temperature is observed in a conductor by passing some current. Let's say current is I and its resistance of the conductor is R. So I can write the 5 degrees is proportional to what? Heat produced, that is I square into R. Alright, and when the current is double, so I prime is 2I, but the wire is same, means resistance is same. So then I can write the delta T, temperature rise, will be proportional to what? 2I whole square multiplied by R, and that comes out to be how much? Proportional to 4I square into R, and this is equal to 5. So means delta T will be proportional to equal to, you can write it's 20 degrees Celsius. That's your answer. 20. Option matches, answer matches with option C. 26. Oh sorry, this is 27. This is 28. So here the balance point in the meter bridge is 60. Okay, so in meter bridge actually we have one wire. Normally it's like higher. Okay, so here this is meter bridge wire and balance point is at, so this is normally in standard it's 100 centimeter. Balance point is at 60, so it means this is 60 centimeter, that means it's 40 centimeter. The ratio of resistance in the gap, so this and this resistance, so this ratio is proportional to this length, this resistance is proportional to this length, so I can write here R1 R2. So R1 by R2 is directly proportional to 60 by 40, that comes out 6 by 4, that is equal to 3:2. And answer matches with C option. Question number 29. In a potentiometer experiment, the balancing lens with the secondary circuit. So I think you should be clear with the potentiometer system here. What we are using here, direct formula is there for internal resistance. R is equal to, it's L1 by L2 minus 1 multiplied by resistance external, that is used in secondary circuit R. So we can use, this is L1 is 480, this is 420 minus 1 multiplied by its resistance is 8 ohm. And solving we are getting R is equal to, this is how much? 60 divided by 420 multiplied by 8, and this is 8 by 7, that comes out to be 1.14 ohm. This is your answer, matches with option A. Question number 30. So here the capacity of parallel plate condenser is so C is 5 microfarad. When a glass plate is placed between the plates of the condenser, its potential become 1/8. Okay, so some charge will be there, Q, and I can write Q is equal to CV, so this implies V is equal to Q by C, right? And this is initial case. When some glass plate is placed between the plates of the conductor, its potential become 1/8 of the original. Okay, so glass plate means dielectric. So when dielectric is inserted, then C prime become K C naught, and here Q will be remaining constant. So this implies your V prime will be equal to what? Q divided by C prime, and this is given as, if I am taking V naught, then it's V naught by 8, is it? And this V naught is equal to what? So you can write Q divided by 8 C naught, and here if I am substituting here on this, so this is equal to Q is Q, and C prime is what? K C naught. K C naught. Simplifying, this implies K is coming out to be 8. This implies K is equal to 8. So dielectric constant is 8, and your option like C is correct answer. Question number 31. Separation between the plates of the parallel plate condenser D and the area J's and slab of thickness of dielectric constant thickness is between the plate. Okay, so here it's like straightforward. Derivation should be there in your like theory part, and it's a straightforward formula based problem. So when dielectric is inserted between the plates of the capacitor, this is K, thickness T, then C equivalent is given by A epsilon naught divided by D minus T plus T by K, and simplifying it, C equivalent, we are getting A epsilon naught D minus T, it's 1 minus 1 by K, and this option matches with your C. Answer matches with option C. Next question number 32. A spherical condenser radius, outer radius, okay, this. So spherical capacitor R1 R2, then his like C is equal to 4 pi epsilon naught R1 R2 divided by R2 minus R1, and here it's given spherical condenser, the outer radius, so means R2 is R, and difference in the outer and inner radius means this R2 minus R1 is given as X. I can substitute the values there. This implies C is equal to 4 pi epsilon naught, R1 is R minus X, R2 is R, and R2 minus R1 is X. So this is proportional to what? R into R minus X by X, and that option like matches with like your option C. So okay, so next question number 33, and here it's asking about the electric field between the plates of the charged capacitor, and E is given by Q divided by A epsilon naught. So here it directly proportional to distance, no. Directly proportional to distance, no. It's not depending on distance, so D is the correct option. 34. Force between the plates of the force अपन को पूछा गया है, and like capacitor C, potential V, separation D. So Q is equal to CV, and electric field is V by D between the plates of the capacitor. This is the net field, but force on the plate will be due to, like if I'm talking about the force on this plate, then force on this plate will be only due to the electric field by this plate. So electric field due to this plate, field due to single plate will be E by 2, and that is V by 2D, right? And force is equal to Q into E. This coming out to be, you can write E by 2, that is equal to CV into V by 2D, that is half, like you can write CV square by 2D is the answer, and which is matching with option A. Question number 35. So next it's saying two metal sphere of capacitance, this and C2 carries some charges. They are put in contact and then separated. The final charge Q1 Q2 are on them satisfied. Okay, so here like when spheres or capacitors connected and like brought in contact, then the charge transfer takes place up to the point when the potential of both the like capacitor is not becoming equal. So when potential become equal, then charge sharing stops. So means like C1 and let's say Q1, next C2 and Q2 is the charge, then potential V, I can write V is equal to Q by C. So V should be equal to Q1 by C1 should be equal to Q2 by C2, and this implies here your Q1 by Q2 will be equal to C1 by C2. This will be the condition, and that matches with option B. 36. Two identical charged spherical drop each of capacitance C merge to form single drop. So here we have drop, identical drops, capacitance C1 4 pi epsilon naught R, right, and two merged to form single drop. So the radius we can write 4 by 3 pi R cube multiplied by 2 should be equal to 4 by 3 by volume conservation pi R prime cube. This implies R prime is equal to R into cube root of 2. So this is the new radius. Then here, right, it's this is given as capacitance C. Now it's saying the resultant capacitance. So C resultant will be what? 4 pi epsilon naught into R prime, and that comes out to be 4 pi epsilon naught into R into cube root of 2. And this quantity will be definitely less than 1 and greater than less than 2 and greater than 1. So your answer here C will be like this is correct, less than less than 2C and greater than, this quantity is less than 2C and definitely, so C prime is less than 2C and greater than C. Okay, so that C is the correct option. Next, problem number 37. It's saying condenser having capacities 2 microfarad, charged to voltage 200 volt, and the plates of the capacitor are connected in resistance. The heat produced, so in here heat produced in the resistance will be equal to the energy stored in the capacitor, and energy stored in the capacitor is half CV square. So energy stored in the capacitor is half CV square, and this is 1 by 2 into C is 2 10 raised to the power minus 6 into V square, that is 200 into 200, and simplifying it, 2 gets cancel, it's 4 into 10 raised to the power, it's 2, so it's minus 2 joule, and that option is C. Question number 38. Steady current I is flowing through the conductor of uniform cross section. Any segment of the conductor has. So question number 38. When current is flowing through the wire, at that point of time the net charge on any point or any part of the wire will be always 0. It just transfer of electron from one atom to another. Overall the conductor remains neutral. So here you can write 0 charge will be there. So A will be your right option for question number 38. Question number 39, let me erase it first. Okay, next question number 39. So it's asking potential difference between point A and B. See, these three resistors are in parallel, so means potential difference across these three resistors will be 2 volt. So the current in this arm will be I can write simply these are 3, so potential this will be equally divided among these 3. So potential difference across A and B will be potential difference across these 2 resistors, and that I can write 2 by third of potential, you can write basically this. So this comes out to be 2 by 3 into 2, that is equal to 4 by 3 voltage. This is your answer for question number 39. Next, question number 40. So two resistor R1 R2 having R1 greater than R2 connected in parallel for the equivalent resistance are the correct statement. So this must be you must be familiar. Actually in parallel combination R equivalent R1 R2 divided by R1 plus R2, this is less than this smaller value. Means this quantity is less than or even smaller than the smaller value of R1 and R2. So that means it will be definitely smaller than. Actually here just you can take 2 examples, let's say 2 and 3, then R equivalent will be what? So these are 2, and here you can write here R1 is greater than R2, so this is R1 is 3 and R2 is 2. Then what is R equivalent? So this comes out to be 2, means 6 divided by 5, that is equal to 1.5. 2 ohm, and you can see it's even like smaller than the smaller value, right? So that means like R equivalent, R will be smaller than definitely R1, and it will be even smaller than R2, but there is no option, and it will not be greater than, so it will be like smaller than. D is your right option. This R is smaller than R1, right? So R is smaller than even this and smaller than this, which is actually the correct option. Remaining you can check. It's greater than 2 means this, it's definitely not, so that's not right. So D is correct option. Next question number 41. The current in the adjoining circuit will be, so here you have simple circuit, this, and it's 30 ohm, 30 ohm, 30 ohm, and this is how much? 2 volt. So current I is asked. So it's like R equivalent across this 30 in series and 30 in parallel, and that comes out to be basically, so R equivalent is equal to 60 multiplied by 30 divided by 90, and this coming out to be 3, it's 20 ohm. So I is equal to what? 2 divided by 20, that is 1 by 10 ampere. That's your answer, and it's matching with C option. Question number 42. In the circuit, the potential of point E is, so here this is, and it's A, B, C, and this is D. So here like it's 8 volt and resistance it's 1 ohm and it's 5 ohm. So the current in this circuit will be like this way, and I is given by 8 divided by 6, that is 4 by 3 ampere, right? And potential here is 0, and here 0 potential, and it's like you can see the current is going in the direct, like current is going this way, so potential like current flow in the direction of decreasing potential, so means here potential should be higher, and that is 0. So this is point E, so potential of point E should be less than 0, and that is equal to I into R. So VE, you can write either VE minus VC, that is equal to like 4 by 3 into 1 minus, that is minus 4 by 3 volt. So your option is C here. 42, C is correct option. 43, let's see that. Sorry, this is did I missed something? Just 1 second. This is question number 42. This is question number 43. I missed actually 41 question number. Let me explain. This is 41 question number. A wire of resistance R is divided in 2 equal parts. These are connected in parallel. The equivalent resistance of each connection, resistance of such connection. So resistance R divided into 10 equal parts. So means R prime is R by 10, that is 0.1 R. And when they are connected in parallel, then R equivalent is equal to R prime by 10, that means it's 0.1 R divided by 10, that comes out to be 0.01 R. So this is your R equivalent, and that answer is A, matches with A option. Next question number, so 44 and 45. Next question number 44. So here we have 2 wire of equal resistance. So let's say this is a, and rho 1 L1 and area of cross section A, rho 2 L2 and area of cross section A. Respectively joined in series, the equivalent resistivity. So first, like R1 I can write rho 1 L1 by A, and R2 is equal to rho 2 L2 divided by A. When these are connected in, actually like this is your effective resistance, then L will become your L1 plus L2, area will still remain A, and resistivity, let's say rho equivalent. Then I can write R equivalent is equal to rho equivalent into L1 plus L2 total length divided by area. And like these two resistances, like here this is R equivalent, when these are connected in series, then R equivalent, here you can write R1 plus R2, that is equal to rho 1 L1 upon A plus rho 2 L2 upon A. So this should be equal to this, and that means rho 1 L1 plus rho 2 L2 divided by A. Just simplifying it, we are getting this implies rho equivalent is equal to rho 1 L1 plus rho 2 L2 divided by L1 plus L2. This is rho equivalent, and that is matching with answer A. Next, question number 45 and final. In the circuit shown here, what is the value of the unknown resistance R so that the total resistance of the circuit between P and Q? Okay, so यहाँ पे आपको circuit दिखा है P, this is this, and this is Q, this is P, this is given 3 ohm, 10 ohm, 3 ohm, R, and R between P and Q is given as also like R, so it will be like 3 plus R multiplied like in parallel with, and so R PQ I can write it's 3 plus the equivalent this, so that is 10 into 3 plus R divided by 10 plus 3 plus R, and this is given by R because R PQ is given as R, right? We can simplify it actually. So this is 10 into 3 plus R divided by 13 plus R equal to R minus 3. We can multiply it 30 plus 10R equal to, this is R minus 3 into 13 plus R. You can simplify it, and solving actually you will get quadratic equation, or either I can simplify it 30 plus 10R. This is 13R and plus R square, and this is minus 39, okay, 13R, and this into this, and 13R and minus 3R. Okay, so it's basically 13R minus 3R, so it's 10R, and 10R gets cancelled, and it's R square, and taking it this side, this implies R square is equal to 69 and R is equal to under root 69 ohm. This is your final answer, and here it matches with option C for 45. So this is all about your solution for problem like paper DT03 for NEET. I hope you understand everything. Like still if you have problem, you can post or comment, I will try to answer that. Thank you so much.